Hello viewers, welcome to the eMath learning platform by Peter Ikaja. I am now going to take you through one of the O-level topics, and that is similarity and enlargement. Now remember to visit YouTube in case you have not subscribed, and make sure you subscribe so that you continue receiving updates whenever I upload new content. In case of any questions or inquiries, my contact details together with the email are here below. Now let's move direct and talk about what we call similarity. Now, when we talk about similarity, we are looking at a situation where two figures or two geometrical figures are considered to be similar. And we are saying two geometrical figures are said to be similar if they have the same shape but not necessarily the same size. That is a point for you to note. Now, their corresponding angles are always equal and their corresponding sides are always in the same ratio. What do we mean by this? Let's look at the illustration. Now, in our illustration, you realize we have two triangles, ABC and PQR. But if you look at the two triangles, they are actually not the same in size, but they look alike in shape. So the mere fact that they look alike by shape, and even looking at the angles are corresponding to each other. So if this is alpha, this is also alpha, theta, this is also theta, and phi, this is also phi. It means these two triangles are considered to be similar. Now, by similarity, what we do is, when you get the ratio of, for example, AB, if I get AB, I will compare it with PQ. If I'm considering BC, I will compare it with QR. Then if I'm consider AC, I will be comparing it with PR. Now, what does it mean? It means when I get AB out of PQ, it is as good as getting BC out of QR, and it is as good as getting AC out of PR. So you simply take a ratio of the two corresponding sides. When you do that, you will come up with what we call the linear scale factor. Now, when we go to some examples, we shall try to illustrate that the more. Now, question 1 says, the triangles ABC and ADE shown below are similar. Now, when you look at the two triangles, we have two triangles in one. ABC is the bigger triangle, and ADE is the smaller triangle. What do they want? They're saying, given that DE is parallel to BC, find length AD. They want us to find this length AD. Now, what you do in this case, the mere fact that we know there are two triangles which are actually similar, to make life so easy, you can first draw them separately. But after drawing them separately, you realize we are looking for AD. And so for my case, I'm going to call length AD to first be X. Now, when I call it to be X, then it means for the bigger figure ABC, the whole of length BA will be 5 centimeters plus X centimeters. That is why I'm saying 5 plus X centimeters. This BC will remain as 12 centimeters. And that is how this figure came about. Then now we also bring out this triangle ADE. And when you do so, we shall have this. Remember, we called AD to be X. This is 8. So we have X here and 8 here. Now, how do we get the value of X? What you do, you simply compare. Now, if I look at this side AB, I'm going to compare it with AD. And if I look at BC, I will compare it with DE. So it means I'm going to say AB divided by AD is as good as BC divided by DE. So that will be our first step. Then, when you get back to your diagram, AB is already given. If you can see, AB is 5 plus X and AD is X. BC is 12 centimeters, and DE is 8 centimeters. So we simply substitute. So we have substituted for AB as x plus 5, AD as x, BC as 12, and DE as 8. Then from this point, we are simply going to cross multiply. So it will be 8 into brackets x plus 5 is equals to 12 times x, which is 12x. Open this bracket on the left hand side. So 8 by x will give us 8x, and 8 times 5 will give us 40, which equals to 12x still. Then here we simply solve for x, but remember we have 8x and we have 12x. So what you do, you collect the like terms. When you do so, we are now taking the 8x the other side, such that we have 12x minus 8x, giving us our 40. Then when you do the subtraction, 12x minus 8x will give you 4x and is equals to 40. And from this level, you simply divide through by 4. And when you do so, you will come up with x as 10 centimeters. So how do we conclude? We now say length AD is indeed 10 centimeters. And we shall have perfectly answered our question number 1. Let's look at question 2. In the figure below, AB is equals to 6 centimeters, AD is equals to 2 centimeters, CD is equals to 4 centimeters, and CE is equals to 5 centimeters. If ED is parallel to AB, find the length AE. Let's look at our figure now. So this is how our figure looks like. So they have given us this figure, but again, before you go on to even answer question, you realize there are two triangles still that we can obtain from here. One of the triangles will be ABC and the other one will be EDC. So like we said, you simply draw the two triangles. Now this is our ABC and this is our EDC. But getting back to the original diagram, remember they are telling us to find the length AE, which is this length AE here. So I am simply going to call length AE to be y first. So if this length is y, then it means length AC will all be y plus 5 centimeters. Remember, AB is already known as 6 centimeters, ED is 2 centimeters, and CD is 4 centimeters. So if we proceed to the solution, you will realize that I've just changed this because I added 5 plus the y, which we placed there to replace or to represent length AE that they want from us. Then from here we do the comparisons again. So again here, when I say AC, I will compare it with EC. So it means it will be 5 plus y out of 5. Then I equate it to 6, which is AB, out of ED. So it will be 6 out of 2. Because we said when you get this ratio over this, so I mean this over this, it will give you the same value as 6 out of 2. So that is going to be our next step. So we're going to say SC, which is this, out of EC, which is this, divided by, is equals to AB, which is that, and ED, which is this one here. Then we substitute. Now remember, AC is 5 plus y, EC is already here, it is 5 centimeters, then is equals to AB, but our AB is 6 centimeters, and ED is 2 centimeters. So I've simply substituted. Then from this point, we shall simply cross multiply. When you cross multiply, you will get 2 into 5 plus y is equals to 30. Then from that point, you open the brackets. So 2 times 5 will give us 10, and 2 times y will give us 2y, giving us 30 on the right hand side. Then from there, we simply solve for y by taking the 10 the other side of the equal sign. So when you subtract 10 from 30, you get 20. Then if you divide by 2 again, you will come up with y as 10 centimeters. So it means we can now conclude that our length AE, which was initially represented by y, is actually 10 centimeters. Let's move on to question 3. Now the triangles ABC and PQ. The question says the triangles ABC and PQ are shown below are similar. So let's look at the triangles. Yeah, they have given us these triangles ABC and PQR, and they have told us they are already similar. What is the question saying? Find the lengths. Part A, PQ. Part B, BC. Now let's look at how to look for PQ as part of our question. Now PQ, as you can see, is here. Now it is also okay to begin considering the small figure, then you end up with a bigger one. In the previous two examples, we always started with a bigger figure, but the vice versa is also true. So if I'm looking for PQ, I will simply compare PQ with AB, as you can see. Then after that, I'll look for two given sides which have all the given information. And because we have all the given information, then we shall use it to look for PQ, PQ being an unknown. For example, I've said here PQ out of AB is equals to PR. When you look at PR, we have 10 centimeters. Is out of SC, which SC is also given as 30 centimeters. But remember, when you begin with a smaller figure, you make sure you still maintain it. That is why you see here PQ out of AB from the bigger one, then PR is again from the smaller one, out of SC from the bigger one. Make sure you don't mix them up. Begin with the smaller one, maintain the order. If you begin with the bigger one, you also maintain the order. So we're going to substitute for AB. AB is already known as 9 centimeters. We're going to substitute for PR. PR is also known as 10 centimeters. And we're going to substitute for SC, which is also known as 30 centimeters. So when you do so, this is what you come up with. But remember, 10 and 30 can be reduced. 10 out of 30 can be reduced to 1 out of 3. Then after that, we simply multiply through by 9 such that we are able to get the value of PQ. So I got 1 out of 3 from 10 out of 30. Then I multiplied both sides by 9. And this gives us a third times 9, which gives us 3 centimeters. Then we can conclude that now length PQ is actually 3 centimeters. Let's go to part B of the question. Now part B says we look for, when we go back to the question, we look for BC. Now where is BC? BC this time is here. What can we compare BC with? Automatically BC will be compared with QR. So we shall say BC out of QR is equals to. Now you can take up any two sides as long as they have all the required information. So I'm going to say BC out of QR, as we shall say here, is equals to SC out of PR. But remember, you know SC already, and you know PR already. You also know QR. So when you substitute, QR is 8 centimeters, SC is 30 centimeters, and PR is 10 centimeters. This will give us 3 if you divide 30 by 10. And after that, we simply multiply through by 8 to give us 3 by 8, which gives us 24 centimeters as our length BC. So the conclusion is that our length BC is actually 24 centimeters. So that conclusion should be only once. And so from that point, I really believe you have picked up. Allow me end at this point, and we shall continue to the next tutorial, whereby we shall develop more and more about similarity and enlargement. Have the best of your time.